history with absolutely zero change in this dynamic. This caused every society on the planet to live in a social steady state, which means that there was no change in the rate of energy conversion at all. There was no fundamental change in how people worked to produce goods, and so scarcity prevailed everywhere. Now, just prior to the year 1800, a very significant event occurred. In 1782, James Watt developed the first steam engine. This invention was the beginning of an entirely new way to do work. It was the beginning of the widespread use of non-human energy, and since that time there has been an accelerated effort to build bigger, faster, and more efficient machines to convert energy into work. That effort has spread throughout the world, with the United States as a primary leader. Over the next 100 years, from 1800 to 1900, we find that the two energy lines started changing significantly. The non-human energy line moved up, and the human energy line moved down. In America, studies were done in the 1920s to see what social impact this change was having. Data was gathered on every basic industry in North America, charting the growth of production, the rates of energy conversion, declining man-hours, and the overall effects on employment. It was predicted that if the trends continued at the same rate, the lines would cross and look like this. Humanity was evolving from a low-energy society to a high-energy society as the two lines switch places. This new condition is the exact opposite of what had occurred all throughout recorded history, and that is no small change. Time to get a bit technical, so bear with me. As of 1992, noted by the U.S. Department of Commerce and Census, America had over 35.3 billion horsepower of installed prime movers. What does that mean? Prime movers are mechanical engines, turbines, and work animals, which originally convert fuels or force, such as wind or falling water, into work and power. Let's break it down by person. Prior to 1800, the average society had an energy conversion of just 2,000 kilogram calories per person. Does that number sound familiar? What is the calorie intake that is labeled on virtually every food item you buy? A 2,000 calorie diet. So it makes sense that if people are the primary workers, their energy is limited by their average calorie intake. Now back to 1992. 35.3 billion horsepower equals over 22 trillion kilogram calories, and the population of the United States was just over 250 million people. So in 1992, America was converting more than 89,000 kilogram calories per person of just non-human energy. That is over 44 times larger, a gain of over 4,000% as compared to the average society prior to 1800. This was a significant source of American growth and prosperity. We were the first and only country that was able to produce more than it could consume. Fast forward to today and consider these implications in our globally connected world. So what does the monetary system have to do with all this? The monetary system has started to falter over the past 90 years because the conditions of life on this planet have drastically changed. The two major requirements of the monetary system to survive, scarcity and growth, no longer truly exist. The globe has stabilized as far as growth is concerned, and scarcity has been eradicated by technology. As a result, we've experienced serious economic problems, and any solution that has ever been tried has served only as a patchwork solution of bubblegum in a cracking dam that is destined to break. No solution ever addresses the fundamental problem, because to do so would require a fundamental shift in our economic structure, and the people who have benefited the most from this system refuse to change the game. The surveys done in the 1920s covered every manufacturing industry, which were then plotted on charts. This chart is a summary of all those findings averaged together. The first line reflects physical production. From 1830 to 1900, production was low and growth was slow. Then we moved into a period of rapid growth. This was due to advances in technology and machinery, and a greater use of non-human energy. From 1900 to about 1930, there was a spectacular exponential growth in physical production, at about 7% per year compounded each year. However, this could not last forever, and a leveling off occurred. Now let's add another curve to show what was happening to the man-hours per unit. This represents one person working 1 hour, regardless of their task. Notice in the early 1800s that man-hours were high, but then dropped as industry developed. This was inevitable, because it was cheaper to use technology versus people. A kilowatt-hour will do the work of 26 man-hours, but at a far less cost. The monetary system encourages businesses to replace costly manpower with cheaper and more productive technology in order to maximize profit. Now, from the 1980s onward, we have a unique situation that has never been present throughout the history of mankind. High production with far less human work needed. This would be great for everyone were it not for the interference of the monetary system, because labor is a major commodity that is bought and sold in the marketplace. Time for a third curve, which shows you what happens to labor and consequently what happens to purchasing power. This third curve represents total man-hours, the sum total of all time put in on the job in manufacturing by all people. As you can see, from 1830 to the turn of the century, total man-hours was low and the growth was slow. It followed the growth of production very closely, as they are directly related. Then it also grew along with production, but it didn't level off like production did. It reached a peak and then turned downward. This is an event that occurs in every industry. Total man-hours rises to an all-time high and thereafter declines. It is an event that occurs only once in any given industry. The peak of man-hours in the United States occurred in 1920, and since then the monetary system has endured instability because of the discrepancy between production and man-hours. The ever-widening gap between production and man-hours indicates that the easier it is for us to produce more, the harder it becomes to distribute. The reason for this anomaly is that there is a close relationship between total man-hours worked and purchasing power. Most of us receive our income from time on the job in the form of wages or salaries, and declining man-hours usually means declining purchasing power. Isn't it ironic that as we increase our ability to produce, we suffer a diminishing ability to consume? This is what happens in the monetary system. The basic problem today is not balancing the budget, but balancing our newfound global resource management capability with global consumption. The rules of the monetary system prevent us from doing just that. Distribution is carried on by a series of exchanges based on scarcity values that no longer truly exist, and money is used to make these exchanges. Money is a species of debt, and we try to balance production with consumption by creating even more debt. This does not work. The reason is because there is little relationship between the creation of debt and anything in the real physical world. Debt nor money is a real resource we need to live. It's a contrived human creation that is no longer valid in today's advancing world. The man-hour curve is a physical phenomenon, whereas the growth of debt is an abstraction. Let's look at the growth of debt and you will see the difference. This chart represents total debt in the United States, all debt public and private. From 1860 to the end of World War I, debt was low and growth was slow. Then, after the armistice in 1918, debt moved up rapidly. This was a period called the Roaring Twenties. The reason for this increase in debt was because technology had caught up with us. During the war, we installed more technology to replace the workers that were off fighting the war. Purchasing power dropped, and we could produce more than we could readily sell. Therefore, during this decade, the institution known as